Hello, algebra students. Mr. Lawrence here, and I know many of you had your minds blown yesterday when we proved that 9/10 repeating was the same as 1. Gray matter everywhere. Don't visualize that. Anyway, gonna blow your mind again. I'm gonna show you a problem that the Algebra Light kids know how to do. And it seems very difficult, but it's simple. So let me read you this problem. It says several friends chip in to pay for a pizza. If each person needs to pay $2.72 repeating, can you determine the minimum cost of the pizza and the minimum number of friends that chipped in to buy the pizza? Now, you're thinking, Mr. Lawrence, I don't have enough information to do this problem. Actually, you do. And like I said, it is simple. So check this out. Let's pretend for a minute that some people were going to get together and buy a pizza. Maybe Ari's going to do it, and maybe Jacob is going to help buy the pizza, and maybe Mr. Lawrence is going to help buy the pizza, and let me see, David's going to help buy the pizza. Okay? And if we wanted to figure out how much each person had to pay, we would find out the total cost of the pizza, right? The total money, and then we would divide it by the number of people that are chipping in to pay for it, right? Okay, so that would be, if it was a $25 pizza, we would divide it by 4 in this case, and that's how we do it. Remember this, total money over number of people. Now I'm going to go ahead and erase this, get this out of the way, and just remember that, total money divided by the number of people. Okay, so what we're going to do is we're going to start with the money that each person has to pay. And that would be $2.72 repeating, right? Now, yesterday we learned how to turn repeating decimals into fractions. So I'm going to do that. Now I'm not going to use the $2. I mean, I can, but it's going to blow up my numbers and make them larger versions of the same fraction. Not larger versions because they're actually equal, but they'll be like unsimplified versions. And so if I don't use the $2 right now and just convert the 7200ths into a fraction, it'll be easier to simplify, and then I'll add the $2 back in later. Okay, so here's what I'm going to do. I'm going to let n equal 7200ths repeating. Okay, and like I said, you could put the 2 there. It just makes the problem a little more work, and I like less work. Now I'm going to multiply by n by 100, right? Because I'm 72 hundredths. So I'm going to multiply by 100 n, and I'm going to get 72 and 72 hundredths repeating. Then, of course, I'm going to subtract minus n and minus 72 hundredths repeating. Okay, so I get 99n, which will equal 72. All right, doing good here. Now I'm going to divide by 99. And notice I didn't use a division symbol. Don't use the division symbol, use a fraction bar. I'm going to divide by 99. And then n is going to equal, if I want to simplify that, I know 9 goes into both of those. So I'm going to divide by 9 in the numerator and divide by 9 in the denominator. And I'm going to get 8/11ths. So the fractional part of this money is the same as 8/11ths. All right, so I'm going to take the $2 and 8/11ths, right? Well, now I'm going to turn that into the mixed number, or into an improper fraction. And so I'm going to multiply 11 times 2, which is 22, and then I'm going to add 8. And so I'm going to get 30/11. Okay, now remember before we said total money over number of friends? I know how much the pizza cost. The pizza cost $30. And there were 11 friends. Isn't that cool? Doesn't that just like blow your, like, your mind has been blown. This seemingly impossible problem is so simple if you know how to convert a repeating decimal into a fraction. And if you know that a fraction is just a division problem in disguise. Now, if you didn't believe me, you could check yourself. Let's check it. I mean, because, don't just take my word for it. Let's take the $30. Let me make that a little bit bigger. Okay, I'll take the $30, and I'm telling you that if 11 friends chip in to pay for it, this is how much each one would pay. And look at that, $2.72 repeating over and over and over again. Pretty cool stuff, isn't it? All right, let's try another one here. Let's try another one. Okay, so some friends chip in to buy season tickets to the world champion Cleveland Cavaliers. If each person is responsible for paying $363.63 repeating, can you determine the minimum price of the season tickets and the minimum number of friends that bought the tickets? Now, you guys wouldn't know this, but in the 90s, the Indians were an incredible team, especially in 94, 95, and 97 was kind of a surprise year. But they never won the World Series, but they got there twice in a 3-year period, and man, they came close. But anyway, what people would do is they didn't want to go to all the home Indians games. I mean, there's 81 home Indians games, but they would get like 5 or 10 friends together, and they would buy 81 games, and then they would divide them up evenly, and they decide who gets what games. Okay, so they get season tickets, but they'd save money. Anyway, that's what we're talking about in this situation. So we have this number here, this $363.63 repeating. I'm going to convert the decimal part of it into a into a fraction. So I'm going to let n equal 63 hundredths repeating. I'm going to multiply by 100, and I'm going to get 63 and 63 hundredths repeating. And then I'm going to, 100n, sorry. Going to subtract n, and I'm going to subtract 63 hundredths repeating. I'm allowed to do that because they're equal to each other, right? And so when I do that, I'm going to get 99n over 60, or equals 63. And of course, I'm going to divide each side by 99, right? And so n is going to equal, if I simplify this fraction, it's going to be 7/11ths. And so now I have 363, hold on a second here. I got to put the 363 out front, right? 363 times 7/11ths. And I'm going to turn that into a mixed number. Now before I do, there's a really cool trick for multiplying by 11. You probably don't know it, but so let me teach you. All right, let's say I wanted to do 45 times 11. I can do this like in no time. This is 495. You see that? How quickly I did that? Let's say I wanted to do 62 times 11. All right, the answer is 682. Can you tell what I'm doing? Can you see it? How about if I want to do 4,524 times 11? Well, I think it's going to be 4, 6, 7, 9, and 4. Let's check that. 4524 times 11. Because you can't just take my word for it. 4524 times 11. 49,764. 49,764. Yeah. If you haven't figured out what I'm doing, I'm just adding. That's all I'm doing. Let me get my different color here. This 4 here is there. 2 plus 4, 6. 5 plus 2, 7. 4 plus 5, 9. And then this 4, the lead 4, is here. Over here on this 2-digit one, there's the 2, there's the 6. 6 plus 2 is 8. See how simple that is? Now you do have to be careful if you have to carry. So like, for example, if I had 785 times 11. Got to be careful with the carrying. The 5 is going to come down. 5 plus 8 is 13, but now I got to carry a 1. This is 15. 7 plus 8 is 15, plus the 1 is 16. And I got to carry the 1 instead of 7 being in front. It's going to be an 8. See how simple that is? It is so simple. Here, why don't you try this one? I'll give you one with carrying and one without. Okay, so I'll give you one without carrying first. Problem A, we'll call it. I want you to multiply 2,413 by 11. Okay, that won't have any carrying in it. And then the second problem will have some carrying in it. It'll be 700, I don't want to use 8 again, I just used 8. Let's go 748. There we go. And we'll multiply that by 11, okay? So you can pause the video and do those really quick. And then when you're ready, watch, here come my solutions. All right, this first one here, it's going to end in a 3. 1 plus 3 is 4. 4 plus 1 is 5. 2 plus 4 is 6. And I put the 2 out front, and there we go. All right, over here, I've got an end in an 8. 4 plus 8 is 12. I'm carrying the 1 in my head. That's 11 plus the 1 is another 12. Carry the 1 is 8,228. All right, so let's apply that up here. When we do our mixed number, we're going to have to do 363. I'm sorry, to go to an improper fraction from the mixed number, we'll have to do that, right? Well, will it end in a 3? This will be a 9. That'll be a 9. And it'll start in a 3. And then I'll have to add the 7, right? So plus 7. That's a 7 there, sorry. That'll be a 0. And I'll carry the 1 to make a 0, and I'll carry the 1 to make a 0, and I will carry the 1. So this number as an improper fraction is 4,000 divided by 11, or 4,011ths. How much did the season tickets cost? Well, they cost $4,000. Yep, they sure did, just my numerator. And how many friends were there? There were 11 in this case. Okay, it's just a coincidence, the numbers I picked, that we got 11 again. All right, this example you're going to do on your own. Well, in your little group there, you can talk about it, okay? Some friends chip in to buy a subscription to an online gaming site. If each friend was responsible for paying $5.77 repeating, can you determine the minimum cost of the subscription and the minimum number of friends that chipped in to buy it? Pardon my yawn there, it's getting kind of late. I don't know if you can see the time. It's 9:47 p.m. You're like, that's not late, but I've been up since about 10 to 5 this morning. So go ahead and pause the video and see if you can figure it out. All right, when you turned 77/100ths into a or into a fraction, you should have got 7/9. Now, many of you probably said, let n equals 77/100ths, and I wouldn't blame you repeating for doing that, but I wouldn't have done that. I would have said let n equal 7/10ths repeating, because aren't they the same number? And then that keeps my number smaller. So I only have to multiply by 10, which gives me 7 and 7/10ths repeating, subtracting n, and I will get 9n equals 7, and then therefore n will equal 7/9 when I divide. Okay, if you do it the other way, you have a little more simplifying to do. All right, so I've got $5.07, right? I multiply and get 45. 9 times 5 is 45, plus 7 is 52, and there's 9 in the denominator. So in other words, $52.09. And there you go. Your minds have been completely blown. A super simple problem that just takes a little bit of number sense. Now, by the way, I had one of your classmates came up and asked me how I could help them become better at simplifying fractions. Well, the real trick to simplifying fractions is knowing your multiplication facts. So if you really want to get good at simplifying fractions, you need to learn your multiplication facts. I would know my multiplication facts at least through 12 times 12. so I would know what 8 times 12 was relatively simply. Okay, that yawn means it is time for me to sign off. So, good luck to you. You have a worksheet for homework, and we'll see you on Monday. Mr. Lawrence saying good night, everybody.